Distance formula. What is the shortest distance between 2 points? We're not thinking of wormholes, right? Not theoretically. So if we review the Pythagorean theorem, a squared plus b squared equals c squared. We can use this to our advantage since this is where the distance formula is derived from. Find the distance between 2, 3 and 6, 7. And there's our distance formula. D equals the square root of, in one set of parentheses, x squared minus, x2 minus x1, and that subscript, meaning you have two coordinates, quantity squared, plus, in another set of parentheses, y2 minus y1, quantity squared. Okay, let's revisit the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. If we try getting rid of the square from the c squared, we do square root, right? So that will leave us with a square root, agreed? So c would equal a squared plus b squared. Okay, distance likewise, notice you have a square root on there. And you have something squared plus something squared. Well, or a group of something squared plus a group of something else squared. And let's remember that's the distance formula. I recommend you have one or both of these formulas at the top of your page. So if you forget your distance formula, remember that you can relate it to the Pythagorean theorem. And then remember that it's technically two dots. So let's plot those two dots. So first coordinate 2, 3, there you go. Second coordinate 6, 7, there we go. And now let's connect them. And as a matter of fact, let's connect them and also make a triangle. So that way we can see that this is technically a triangle, right angle triangle, which is why we can connect it or revert it back to the Pythagorean theorem, which is technically where the distance formula is derived from. So let's realize that the c value, or the distance, is the distance between both of those points. So remember, shortest distance between 2 points, physically as far as we can tell, is a straight line. And let's realize that b is your change in height or change in y direction. Your a is your change in x direction. At least from this point of view, keep in mind you can switch the a and the b. And keep in mind, that triangle there implies delta. You may have seen it on an airline, agreed? So just as a reference, it implies a change. Delta, change. Okay, our coordinates. Let me restate our coordinates. 2, 3 and 6, 7. And do realize, I've labeled the x values red and the y values blue. This has nothing to do with your slope. So even forget I mentioned the slope. And technically, you might confuse this still. So this has nothing to do with it. This is your distance formula, totally different formula. All it has to do is the fact that you have two coordinates. That's it. Two coordinates with an x and a y value on each. So our distance formula is literally that. Some blank spots or blank areas with a square. And you're taking the square root of all of it. So now let's fill in the blank spots. The first set of spots is the x's, where you have the x's. It's a 2 and a 6. The order doesn't matter. If they're negative, you'd have an additional negative sign in those parentheses. Be aware of that. For instance, if that 6 was a negative, you'd have a double negative, which would make a negative times a negative, you are going to convert to a positive. Don't worry, your answer is going to come out positive in the end, but that would still change your answer into the parentheses though. And now for my y values, I have a 3 and a 7. Once again, the order doesn't make any difference. You can switch them around however you look, as long as it's within that same parentheses. So y is with the y's, x with the x. And now let's simplify this. 2 minus 6, 4. 3 minus 7, 4. Hey, happens to be 4 in this case. It's going to make it easier. 4 squared. 4 times 4, 16. 4 times 4 again, 16. So there we go. 16 plus 16, 32. And let's remember to take the square root. So this is where your calculator could come in handy. So turn on your calculators and clear anything that you might have on there. So here are my calculators. So second x squared gives you the square root. So second square root, or x squared gives you the square root. And we're plugging in 32, close your parentheses, hit enter, and there is your rough estimate. 5.66 maybe, roughly, would be a fair estimate. to 5.66 approximately. Once again, squiggly lines means it's a rough estimate. So circle your answer and technically we're done. Remember, it's a distance. So distances, you don't have a plus or minus, even though it's a square root. You only think about the positive distance. So once again, note that for distances, we use only the positive value in the square root. So we don't have to worry about putting a plus or minus in this case.